So we folded this one in half. I need you to fold this one in half. And I need you to fold this one in half. Okay. So you have 3 folded in half, yes? Okay. Pick 2 of them. I don't care which 2. And I'm going to have you open them up. And on the crease that you just made, on the fold that you just made, I need you to cut up about 1 inch. Guys, how much is 1 inch? What part of your body can you compare to 1 inch? Your knuckle right there. That's about 1 inch. Okay?
Is it on both?
On both. On both. Remember I had you choose 2 colors? Yeah. And we're cutting from the top and the bottom in about 1 inch. Got it?
We'll just kind of make it.
Everybody here so far? Okay, take your other piece of paper. Now I want mine to be neat, so I'm going to kind of put it up against the paper that I just cut. I'm going to mark. See, my cut goes down to here, so I'm going to mark a little bit above that. This cut goes to here, so I'm going to mark a little bit below that. So my cut on my green paper is going to be a little bit bigger than the not cut part on the other 2 pieces of paper. Does that make sense? Now watch what I'm going to do. I'm going to barely cut this page. So see how much I cut off? Barely a tiny bit. So then when I open it, I have a little opening. Please try really hard not to waste my paper, okay? So you have 1 page with a hole in the center like this, and you have 2 pages with the hole in the outside. Everybody okay so far? Okay, now I'm not going to fold, but I'm going to curl in like this. Don't make a fold, because then you'll have a weird fold on your paper. Okay, and when I'm folding it in, the outside color is going to be the front color. So if you care, like when I curl this in, the one in the back is going to be my outside cover. Or my front cover, I guess is what I should say. Okay? So I'm going to curl it and then slide it through the hole I just made. If it doesn't fit, just make some real quick cuts so that it fits.
I don't think it's... I don't think it's working too well. How did you mark this?
You okay so far? I'm coming to help. Hold on.
Why is this? What did I do? I want some marker. It's not even. Simple vision. Where was my work on as a kid? Why weren't you teaching me how to do stuff? What did you just say? What? Wait, tell me if I'm doing this right. Folded it like this. Yeah. might need to make that cut a little bit bigger though. I think it's going to need to be a little bit bigger though. And plus, you have it double folded. You're not supposed to do that. You're supposed to have it like that. You don't have to do it exactly thick. Just like that. Wider.
Alright, bro, that's freaking amazing.
Alright, whoa. Do it. I got you. I don't want to listen to nothing. I don't want to listen to this. I'm not working on this. Okay? Is that the right term for You what?
I broke a leg.
You said you crashed out. Oh, wait. No, we crashed out. Just they're cooking some meat.
We have nothing in the house.
You?
You are exactly
I see Chelsea eating under the bridge. Chelsea school is huge. Chelsea makes a lot more sense. There's people that told me that we're working at your house.
Okay, are you good? Okay, so what did we just make? Or a foldable, right? It is a book, but it's a foldable, so what do you know about this foldable? You can use it on tests and homework and quizzes, yes? Okay. So let's first of all put a title on this book. What are we going to title this foldable? Factoring. Factoring. And on the back, leave about a little bit of space on each edge, because we're going to add something on each edge, and then put your name in the middle. Okay, so you have space on each edge. Let's go ahead and draw a T-chart on each side. I'll go ahead and fill this in actually since we're here. We're going to call this side x and this side x squared. We're going to call this side x and we're going to call this side x cubed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should be good going to 10. You'll get the idea after that. So what is 1 squared? 1. What is 2 squared? 4. 3 squared? 4 squared? 25. Then what? 36. 7 squared? 49. 8 squared? 9 squared? 81 and 10 squared? Or 100, right? Do I think you know these or not?
Yes.
Yes, I think you know them, right? But sometimes doesn't it help to have it written down, right? So you can refer to it. Okay, so what are we going to do here? Cube it. Okay, so what's 1 cubed? Because 1 times 1 times 1 is 1, right? What about 2 cubed? 8. What about 3 cubed? 27. 4 cubed? 64. 5 cubed? 125. 6 cubed? 216. 7 cubed?
322.
So you guys all have your calculators and you could be figuring this out yourself, right? You might have him right now when we're taking notes, but you don't have him on quizzes or tests, right? What about 8 cubed? 512. 9 cubed? 729. And 10 cubed? Hopefully you can all tell me what 10 cubed is. Right? Okay? Now, we might need to refer to that later on. Okay? But if not, you have it here. Okay? You ready? Okay, factoring. First thing we're going to talk about when we talk about factoring is what we need to look for first every time. What's a GCF? Greatest common factor. So if I have x squared plus x, what is the greatest common factor between these two terms? God bless you. X. And if I factor out an x from each term, what's left? So when I say that, what does that word factor mean to you? If I factor out an x from each term, what am I doing with each term and x? Dividing. So factoring is another, dividing, it's not exactly dividing because dividing was like long division, synthetic division, but factoring is breaking it into its parts, so it's dividing, right? It's just not going to look the same as what we worked on last week, okay? So if I divide this term by x, what do I have left? What? Just x, right? Because x squared really means x times x, and if I divide that by x, x divided by x is 1, and all I have left is an x. What if I divide this term by x? What do I have left? A 1, because anything divided by itself is 1, except for 0, but we don't have to fight about that right now, right? Okay? So what if the problem looks like this? 2x squared plus 4xy. What is the greatest common factor between these terms? So they're both divisible by a 2, and they're, oh, I forgot something, and I fixed it real quick.
Squared.
There's a squared on the y, right there. Okay? But you agree that they're both divisible by 2, and they're both divisible by x, and they're both divisible by y, right? So 2xy is my greatest common factor. What happens to the first term if I divide it by 2xy? If I factor out a 2xy, what's left?
XY.
Is there an x left? No, just a y. What's left if I factor out a 2xy from this term?
2.
Just a 2. So that is factored. Does that make sense? Okay. What if it says 3x to the third plus 6x squared plus 9xy? What's the greatest common factor? Ooh, there's 3 things that I have to look at, right? And it has to be common in all of them, doesn't it? Yes, so what's the greatest common factor? 3x. Now if it was just this, if it was just these two, what would be the greatest common factor? 3x squared, right? But since this is here, all I can take out is a 3x. What do I have left if I factor out a 3x from the first term? X squared. Very good. What about the second term?
2x.
2x. And the last term, if I factor out a 3x? 3y. Right? 9 divided by 3 is 3. X divided by x is just 1, and then I have a y. Excuse me. Any questions about that? Okay? Okay, let's turn to the next page. On this page, I'm going to teach you how to factor the difference of squares. Anybody see why I chose the warm-up problem I chose today?
Yes. So we know what difference.
So you remember what difference meant, right? Subtract. What does difference mean? Subtract, right? So what's going to happen, like here, I kind of tried to put a general form at the top, and then I give you 2 examples at the bottom. For the rest of these, I'm going to put a general form at the top and 2 examples at the bottom. This is not really the general form of greatest common factor, but it was a pretty simple example. You okay with that? Okay. So difference of squares, first of all, I need you to recognize that that is the difference of squares. Do you recognize that that is the difference of squares? Because why? It's subtracting, that's difference. And now how do you know these are squares? Well, it says squared and squared, right? What does it mean for something to be squared? Multiply by itself. That's why we made this chart on the back here, right? So we could recognize numbers that are differences, excuse me, the numbers that are squares, right?
Yeah.
So I don't like to make you guys memorize formulas, because if there's a formula, you're going to be able to look it up, right? Except for one. I'm going to make you memorize one formula this year, but that's for later, okay? I would rather teach you a pattern, because you are more likely to remember patterns than you are formulas, okay? So I want to teach you the pattern for the difference of squares. When you recognize it's a difference of squares, and I say to factor it, you're going to get 2 binomials, okay? At the front of each binomial is the square root of that number. What is the square root of that number? X. That goes at the front of each binomial. At the back of each binomial is the square root of that number. Y. All that's left to fill in is the signs. And I just need them to be opposite. And then you're done. That's the pattern. Square root of the first goes at the beginning, square root of the last goes at the end, and the signs are opposite. You okay with that? So factor this one for me. 4x squared minus 25. Well, if you have 4x squared minus 25, you're going to get 2 binomials. What goes at the front of each binomial? Close. 2x. 2x goes at the front of each binomial. What goes at the back of each binomial? 5, because that's the square root of 25, right? Now tell me about the signs. They are opposite. Plus, minus. And then we're done. What about this one? I'm going to try to trick you like 3 times in this problem. Okay, time out, time out. What's up?
Why do you put 2 binomials again?
That's the pattern.
Yes, ma'am.
That's the pattern, okay? You'll always have 2 binomials when you're factoring difference of squares, okay? All right, now, are you ready for the next example? I'm going to try to trick you like 3 times in this problem. You ready? Okay. 45 x squared y to the 4th minus 80. So first thing, is this the difference of squares? Okay, is this difference? Yes.
But that's not a square.
These aren't squares, but what else do you notice about these 2 numbers? Don't tell me what they are not. Tell me what they are. Divisible by what? 5. So before I can even factor the difference of squares, I have to check to see if they have a greatest common factor, right? Do they have a greatest common factor? Yeah, you just told me they were both divisible by 5. So what if I factor out of 5 from each term? What do I have left? Or 9. 9 x squared y to the 4th minus 16. Huh. Is that the difference of squares?
Oh, it's gotta be 2 over 5 now.
Is 9 a squared number?
Yes.
Is x squared a squared number?
Yes.
Is y to the 4th a squared number?
No,
What times itself equals y to the 4th?
it's 2.
Y squared. So is this a squared number? Yes.
Yes.
Is 16 a squared number?
Yes.
What times itself equals 16? 4. So is this the difference of squares? Yes, it is. So when I have the difference of squares, I get 2 binomials. So I already tried to trick you. I already tricked you once. Had to fix it. We fixed it. Now we're going on, right? Don't get tricked again. What goes in the beginning of each binomial?
3x.
3x
Y to the second.
y to the second. Good. You didn't get tricked that time. 3x y to the second. What goes at the end of each binomial? 4. And tell me about the signs. Okay, so minus plus.
Plus minus. Did they both work?
Does it have to be minus plus or can it be plus minus? As long as they're opposite. Doesn't matter what order we multiply in. No, it does not. Okay? So I tried to trick you. You didn't get tricked. In the general form, I wrote a plus and a minus. In the next example, I wrote a plus or minus. This example, I wrote a minus and a plus. It doesn't matter what order they go in as long as they are opposites. Okay? You okay so far? Any questions about difference of squares? Okay, let's go to the next page. Sum of squares.
Oh, just some.
So the general form looks like x squared. What? What's the general form look like? X squared
Plus
plus
y squared.
y squared. Do you recognize that that is the sum of squares? Okay? This is usually your favorite. Usually.
It's my favorite.
It is. You know why?
Why?
Because you can't factor it. When you recognize it's the sum of squares, you just write prime. What does it mean for something to be prime? Only divisible by 1 and itself. So you cannot factor it. Now, I need to quantify that. Okay? You cannot factor it. I can factor it. My college class can factor it. Kids in pre-cal can factor it. Because you don't know enough yet to factor it. February, March, you'll be able to factor it. Right now, you cannot. Okay? I don't mean that disrespectfully. I just haven't taught you some stuff you need to know to be able to factor it. Is that fair? Okay?
I'm good with that.
For now, when you see that the sum of squares like this, you're going to write prime. It means it cannot be factored with the knowledge you have right now. Okay? Oops, I forgot to underline it. There. Okay so far? All right, next page. Difference of cubes. Now, since this is not geometry, what do I mean by cubes? To the power of 3, or what times itself equals that number, right? Okay, So general form is going to look like what? X cubed, what? Minus y cubed. Okay? Again, we're not memorizing formulas, we're figuring out patterns. Okay? So the pattern for the difference of cubes is a binomial and a trinomial. Okay? Binomial, trinomial. We're going to figure out the binomial first. What's the cube root of this? What's the cube root of this? Okay? Now I'm going to use my binomial to get my trinomial. Okay? Square this. X squared. Multiply these two together. So xy. Now square this one. So binomial, trinomial, right? What's missing? The signs. What's the sign in the problem? Then that's the sign in the binomial. The next space is opposite of that, and the last sign is always plus. That's a general form. Okay? So let's do an example. X cubed minus 8. Well, you know we have a binomial and a trinomial. So let's give ourselves room for a binomial and a trinomial. What's going to go in the binomial? Cube root this. X. And then the other part of the binomial? Cube root this. 2. For the trinomial, square this. X squared. Multiply these two together. 2x. And square this one. So 4, right? What's the sign in the problem? Then that's the sign in the binomial. The trinomial first sign is, because it's opposite of that one, right? And the last sign? Always plus. Okay? 27 x to the third minus 1. Is this the difference of cubes? Because what's the cube root of 27x cubed?
3.
We see 27, we can see the cube root of it right there, right?
Yeah.
And then what's the cube root of 1? 1, okay. So binomial, trinomial. What goes at the beginning of the binomial? 3x. What goes at the end of the binomial? 1. Beginning of the trinomial?
9x squared.
9x squared. Very good. What's the middle term of the trinomial? 3x. And what's the last term in the trinomial? 1. What's the sign of the binomial? Because that's the sign of the problem. What's the next one? Opposite of that, so plus. And the last one? Always plus. Okay, so far. Okay. Guess what's next? Sum of cubes. Now, unlike sum of squares, you can factor sum of cubes. However, you already know how to do it. Because of the way, because I didn't make you memorize a formula, because I taught you a pattern for difference of cubes, you already know how to factor sum of cubes. What's the general form look like? X cubed plus y cubed. Okay, so think about the pattern that I taught you for difference of cubes and tell me how to factor this. Is it going to be binomial, trinomial? Yes. What goes here? What goes here? What goes here? X squared, xy, and here? Y squared. Tell me the pattern of the signs. Plus, minus, plus. Why? How did you know that? This was the sign of the problem. This is opposite of that. And last is always plus. You good? 64x to the third plus 343. Binomial, trinomial. What goes in the binomial? 64 cubed is, or cube root is 4, right? So 4x. And what goes in the second part of the trinomial? 7. What about the trinomial? I think I said trinomial. I meant binomial. What goes here? 16x squared. And then 4x times 7, right? So 28x. And then last part of the trinomial? 49. The pattern of the signs? Plus, minus, plus. 216x to the 6th plus 1,000. Now here's the thing about it. Aren't those both cubes? Yes, but do you also recognize they are even? They're both even, so I can at least take out a 2. Anything else I could take out? A 4. I'm going to finish this for the video, so if you want to go watch the rest of this in the video, you can to fill this out. Otherwise, your homework is on page 236. Okay? You can factor out an 8. And you want to do greatest common factor first, because it makes it a little bit easier. Drag that 8 along. You get your binomial and your trinomial. You get 3x squared and 5. You get 9x to the 4th. You get 15x squared, and you get 25 plus, minus, plus.